Alright, we're going to do this animated example here. We're supposed to take example 8.4 and then modify it a couple times. So let's take a look at what 8.4 looks like. So I have a blank sketch pad here I'm bringing in. This is where I'm going to be able to get my examples under File, Examples, and you can add examples. If you don't have this contributed example, you would want to add that. I'm going to go down to 8.4, take a look at what we have here, and run this. So we have a Pac-Man moving across the screen really slow, and it looks like the Pac-Man just goes off the screen and then starts back at the beginning. Okay, so what we're having here is a code, and we use speed. I'm going to speed it up a little bit because that was really slow. I'm going to make it to 1 just to speed things up a little bit. So we're using X to increment itself and then apply that to the X coordinate on our arc. So X, Y, width, height, start, stop are the parameters for an arc. So if we're updating X in this draw method, as we do in animation, the draw method is repeated. The setup is done at the beginning, the draw method is repeated. This is the same thing as saying X is equal to X plus speed. So speed being 1. Every time this draw method is executed, X goes up by 1. So that will start off at 1, then 2, then 3, then 4. So this would continually move this arc right because X is constantly increasing. So we're going to see that here again, and it should move a little faster with the speed increased. Then it says here if X is equal to a negative radius, which is a negative 40, then we're going to move it to the left edge. So that's how that thing, that's this line here. No, if X becomes greater than width plus the radius, so the width of the screen plus 40, if X gets that large, then we're going to reassign X's value to negative 40, so that will start it off on the left-hand side before the screen even begins. So that's why we see the Pac-Man approaching from the left-hand side, because it's set to start off X at a negative 40. And then again, it just increments that by 1 every time the draw method goes through. It's a little explanation of the code that we're starting with. Now what we want to do here with this code is that we want to make the Pac-Man bounce back and forth between the left and right wall. So right now it just resets. When it hits the right wall, it stops and resets over to the left wall. So what we want to change around is a little bit in our draw method, and in this if statement right here particularly. So if X is greater than the radius, or the width plus the radius, we're going to reassign the value of X, which is not going to be handy for us at all. I'm going to need to create a new variable that I'm going to use for, it's called direction. And I'm going to have it assigned to 1. So this will help me flip that direction back and forth a little bit. Now, I'm going to say X is not only equal to speed, but it's also equal to speed times direction. So if direction is positive, then it will be going in right. If direction is negative, you need to assign the value. Let's make that int. Sorry. Now, if direction is negative, negative times that positive speed will be a negative, and that will push the Pac-Man to the left because X will be getting smaller. That's the first thing we need to do. Now, let's see what we have with our if statement. Width plus radius, that'll be entirely off the screen. So I have the entire width of the screen plus the radius of our Pac-Man. So if X becomes greater than that, then it moves it to the left edge. So what I don't want to have happen is it to be completely disappearing. So I need to make it a little less there. So width minus radius, I really want it to be just the diameter. So in order to do that, I'm just going to divide the radius by 2. So the width of the screen minus the diameter of my Pac-Man. If X becomes that value, then what we're going to end up switching it around. So instead of X equals that, what we're going to simply do is we're going to change direction. So direction will equal a negative direction, and this is going to reverse the Pac-Man. So I'm going to put my arc a little bit higher up here so I know that it. Now let's see what happens when we run this code here. So the Pac-Man is going to go off here, and it's going to bounce off that side and then turn back around and keep going. So that's where it's going to be going. So what we need to do is we need to now create parameters so when the Pac-Man hits the left-hand side, it also bounces back to the right. So this would be what we call an OR statement. It looks like this, 2 vertical lines. Or if x becomes less than radius divided by 2, or the diameter again. And I'm going to need to put all this together in some nice brackets there. Okay, so let's see what we have here. Oh, nothing. Sorry. Okay, I'm going to reestablish where x begins because this is throwing things off a little bit as having it started at -40 here, and this bounds checking is causing some different things to go on. So instead of having it set at a negative radius, I'm just going to give it a hard code of say 100 and see where that puts us. And as we can see, our Pac-Man is now bouncing back and forth between our screens, but it is going off a little bit. Now that has to do with our ellipse mode being set at radius. So if you were to look up the API for processing ellipse mode, you would have these various things here. So we have either radius, center, corner, or corners as parameters for our ellipse mode. And what we need to set it as is we need to set the ellipse mode to center instead of radius. So let's do that over here on our processing to see what that. We need to set it to center, and that is capital letters. Now center mode, if we look here, it's just going to center center it so we can not be shifted off to one side or the other. Now when we run this, we will see our Pac-Man is now kissing off of that wall and hopefully up the back wall as well. Great. So now our Pac-Man is doing what it's supposed to be doing, bouncing between the two walls there. Perfect. Now we need to modify the Pac-Man to flip its mouth when it bounces back from a wall. Okay, so we'll need to be doing another if statement as well as drawing a second arc that will be facing the opposite direction, will be facing left. So let's start that now. We will want to reestablish this drawing this arc in that new conditional statement. So I'm going to just simply comment this out for now. We have our direction being established, and now after that we need to do an if statement to talk about which direction that mouth is going to be facing. And what I'm going to be using is the value of direction, because if direction is positive, then the arc should be facing to the right as the Pac-Man is moving right. And if direction becomes negative, then the radius needs to face to the left as the Pac-Man is traveling left. I'm going to say if direction is, not equals, is 1. So it's going to evaluate whether it's 1 or not. It's not going to assign direction to being 1. It's just checking to see. The double equal sign is to check to see if these two things are equivalent. Then what I'm going to do is I'm going to place my first arc in there that we have. That'll be facing to the right. Now I need to do an else statement. And inside that, I would need to draw the arc in the opposite direction, because then else direction equals -1. And I've already worked this out a little bit. X is X, and Y is 60, and radius is still radius. And now then my new numbers are 3.67 and 8.9. So let's see what we have here. Perfect. Nice. Okay, so our Pac-Man has now moving back and forth, and it's facing different directions depending upon which way it's traveling. Okay, so that's a quick run through on animation, speed and direction, modifying example 8.4.